All right, so this is our chapter 3 solutions. So you can watch the Zoom recording to get the notes if you missed that. And then we also went over some of these questions as well. I believe that should be in the Zoom recording as well, these questions. You may have to skip ahead at times if I was giving the students time to work on them, but those should be there as well. So we left off with this question here, question 4. And this is going to be a quotient rule question. So we're just going to apply the quotient rule, nice and easy question. So just make sure we know how to do it. Low, so 3x plus 2, leave it alone. D high, the top is 2. Minus high, leave the top alone. D low would be 3, all over low squared. And most likely, if you can't get an answer, most likely you can kind of get rid of choice E because it doesn't have the 3x plus 2 squared. It could simplify to that, but if I was guessing, I probably wouldn't guess that. So anyways, we will go ahead and distribute. And you need to make sure to distribute this negative sign. That's important. So the negative sign needs to distribute. And then you also will multiply by the 3. So this becomes 3x times 2 is 6x plus 4. And negative times 2x times 3 is minus 6x. And negative times 3 is minus 9. All over 3x plus 2 squared. So our 6x and negative 6x cancel. We end up with negative 5 over 3x plus 2 squared. So that's choice D. If you did solve this and you got something like maybe you forgot to distribute that negative and you canceled out the 6x's but not the, maybe you accidentally got like plus 13 and so you had 13 over, then just double check your signs and figure out where you messed up. All right, next one is another chain rule one, and this actually has a double chain rule. So, right, if we had y equals ln of x, we need to have memorized that y prime is 1 over x. So if this is the box, right, then times the derivative of the box. So that box here is everything inside. So f prime of x, we're going to do f prime of x first, then plug in 0, will be 1 over x plus 4 plus e to the negative 3x. Now we need to multiply by the derivative of the box. The derivative of x is 1, plus the derivative of 4 goes to nothing. And then the derivative of e to the negative 3x will have another chain rule, will be e to itself, negative 3x, times negative 3. We can just move that up to the numerator. So it's going to become 1 minus 3e to the negative 3x, right? I just moved the negative 3 in front, over x plus 4 plus e to the negative 3x. So that's f prime of x. They asked us what is f prime of 0. So 1 minus 3e to the 0 over 0 plus 4 plus e to the 0. We need to know that e to the 0 is just 1, not 0 but 1. So 1 minus 3 over 4 plus 1 over 5, which is negative 2 over 5. All right, so kind of a double chain rule there. This is a problem we 100% just have to know how to do. I mean, don't think to yourself, this is too hard. You got to get there. Okay, so you have to be able to get to this kind of a question. Doing that double chain rule will definitely be on your exam. All right, next we have is an implicit question. Sorry, not implicit. Sorry, product with a chain. So we're going to do the product. The derivative first is 2x, and then we will leave sine of 2x alone. Then plus, now we're going to leave x squared alone. And the derivative sine of 2x will become the outside is sine. So it'll become cosine of 2x. And then times 2. So this is going to be 2x sine of 2x. Plus I'm going to move the 2 to the front. 2x squared cosine of 2x. What can we factor out of both? We can factor out a 2x from both. So I'll factor out the 2x. That gives me sine of 2x plus x cosine of 2x. So that's choice E. All right, next up we have another one of these inverse questions. So even though they don't say the word inverse, when we see this formula, that is the formula for an inverse. So what I like to do here is create this box. I want g prime of 2, so I'm going to put g of 2 here. Now we know that g of 2 is 1. So that means that f of 1 is equal to 2. Okay, it always goes backwards. Now up in this corner, this is where I put f prime of x. Now if I have an equation, I have to do it. Sometimes they don't give me an equation, they just give me more information, like a table, or they give me a lot more derivatives. This time they didn't. They did give me an equation, right? So they gave me f of x equals x cubed plus x. So f prime of x, right, we're just going to do is 3x squared plus 1. So that's what I put up here, is the formula for f prime of x. And here I put f prime of 1. It's always the same number here, right? And these two are always flipped. So f prime of 1, we're just going to plug in f prime of 1. 3 times 1 squared is 3, plus 1 is 4. And so then our answer for g prime of 2 is always just 1 over that guy. So 1 over 4. All right, so that's just something we have to know how to do. Like I said in the Zoom, is this isn't very super common, but there's a chance that there would be 1 on the multiple choice. There might not be. I've seen a lot of multiple choices where this is just not tested at all. But in most multiple choices, it's just 1 multiple choice question, and then that's it. Next one we have is a particle moves along the x-axis, so that at any time t, its velocity is given by this formula. And this was a calculator question, so make sure you get out your calculator. So our big key here is that we see this word velocity, we see this word acceleration, and we need to just kind of remember our position, velocity, acceleration, that if we're going to move down the table, we're doing a derivative. And if we're going to go up the table, we're doing an integral. So in this case, we have velocity, and we want the acceleration at time 4. So the acceleration at time 4 is just going to be v prime of 4. And if it's free response, you can write it like this. And multiple choice, you don't really have to write anything down, but sometimes it's good to underline things. So we can type it in. I already typed this in for us. Is d dt of 3 plus 4.1 cosine of 0.9t, and then close our parentheses, and then at t equals 4. I see way too many of us trying to do this in 2 steps, and it's just kind of wasting your time, right? Especially on free response. Like what I saw a lot of people do was they would just do this, and then they would write out a of t equals, they'd write the formula, and then they'd plug in 4, and it's just way too much time. You can just totally do it in one line and just get away with writing the answer, 1.6329. So just write 1.6329. If this was a free response question, that's all I have to write. I don't have to write anything else. They know I have a calculator. Right, on multiple choice, I don't even have to really write anything. I can just do it. All right, next one is another calculator question. So they give us a differentiable function. They give us f of 2 equals 3, f prime of 2 equals negative 5. And then they say let g be defined by g of x equals x times f of x. And which one of these would be the tangent line? So even though this is a calculator question, honestly, I did this one without. So whenever I see a tangent line equation, I'm going to put in x1, y1, and m. And I want the point where x equals 2. And it's the tangent to g, right? The tangent to g. So y1 is going to be equal to g of 2, which based on this formula would be x is 2 times f of 2. Well, f of 2 they gave me was 3. So 2 times 3 is 6. And then for my slope, right, well, I need to get g prime, which is going to be product rule. Right, so I knew that basically g of x was x times f of x. So g prime of x is going to be my slope. Right, so product rule is going to be 1 original times leave f of x alone. Then plus, now let's leave x alone, times f prime of x. And so for the slope, we have to plug in 2. Right, so g prime of 2 is going to be 1 times f of 2 is 3. Then plus 2 times f prime of 2 is negative 5. That's going to be 3 minus 10, which is negative 7. So literally just from right here, I know the answer is D, because that's the only one with the correct slope. But, y minus y16 equals m negative 7 times x minus 2. It checks out. So our work checks out. You do want to kind of double check that all of your work does match, because, if it didn't, maybe you made a mistake somewhere. All right, next one. let f be differentiable, and they give us h of x equals f of g of x, and they want us to find h prime of 1. This one has actually been pretty common on multiple choice in the last couple years. Sorry, on free response in the last couple of years. They've kind of had this like other question where they might give a table, a graph, and an equation. And so as part of the table process, they're going to have us do something like this. So anyways, before I can do h prime of x, I want to do h prime 1. I want to do h prime of x. And so this is chain rule. We have to kind of, the outside is that f. So we'll do f prime of, leave g of x alone, and times g prime of x. And this is the formal definition for chain rule that you will see in most textbooks. It'll look something like that. So now we want to do h prime of 1. So we're going to just plug in 1 wherever we see an x. So g of 1 and then g prime of 1. So I have to work inside out for these. So f prime of, now g of 1 is 2. And times g prime of 1 is negative 3. And now I want f prime of 2. F prime of 2 is negative 4 times negative 3, which would give us positive 12. All right, next one says let f and g be differentiable functions. If g is the inverse, so this time they told us inverse instead of giving us the formula, and they give us some information. So again, this is another one of those questions, inverse question. But in this case, I don't have an equation, so we're not going to worry about that guy. So we want g prime of negative 2, so we start off here with g of negative 2. So g of negative 2 they give us is 5. Up here I just switch them. F of 5 is negative 2. And so then here it's f prime of 5. It's always the same one there. Right? It's also the one that goes here on the y, because they're inverses. So f prime of 5 is negative half. So our answer is 1 over negative half, which times 2 times 2 is 2 over negative 1, or just negative 2. Next up we have is a graph, and it tells us that there's a vertical tangent at the point 2 comma 0. So it says a vertical tangent, right? That would be not differentiable. And horizontal tangents at the points 1, negative 1, and 3, 0. So kind of what that told me is essentially that, f prime of 1 is 0, f prime of 3 is 0, and f prime of 2 does not exist. So that's kind of what information they're giving us with those tangent lines. It says for what values of x is f not differentiable? Well, it's not differentiable when it makes that jump and at the vertical tangent. So that's at x equals 0, right? This is at the 0, and then this is at the 2. So 0 and 2. Next one is another chain rule. So outside is sine, and this is going to be kind of like a double chain rule because we have the negative there. So outside is sine, so f prime of x is going to be cosine of e to the negative x, then times, so now e to the negative x, but then that's another chain rule times the negative 1. So it's negative e to the negative x cosine of e to the negative x. And again, this is something you really have to make sure you know how to do. Number 10, what is the instantaneous rate of change? When we see instantaneous rate of change, that just means f prime of 2, because they give us that 2. So this is a quotient rule. So f prime of x, low, d high, minus high, d low, all over low squared. Now, you can simplify it, right? You can distribute and cancel out whatever gets canceled, but I don't do that personally. As soon as I get a number, I just plug it in. That's always worked better for me. So this is going to be 2 minus 1 times 2 times 2 is 4. Minus 2 squared is 4 minus 2 is 2 times 1. All over 2 minus 1 is 1 squared is 1. So it's 1 times 4 is 4 minus 2 over 1, which is just 2. So again, you can simplify first with the x's, but to me it's a lot faster to just go ahead and plug in. All right, 28 is a chain rule that also has to deal with trig. I might recommend that you pause the video here and try this one, because this is something that's good practice for everyone. Just go ahead and pause it, try it, and then keep going. So the outside is that tangent. right? So the derivative of tangent is secant squared of 2x, and then times the derivative of 2x is 2. So we're going to plug in pi over 6. I'm going to bring the 2 to the front. And 2 times pi over 6 is just pi over 3. And this is where you guys might have gotten stuck. But don't really, what you have to remember is just that secant is just 1 over cosine. So you want to remember just, hey, what is cosine of pi over 3? Right, so we have this chart, sine, cosine, and cosine at pi over 3, you should know on the chart, is 1/2. So all we do is we take 1/2 and we just take the reciprocal. So instead of, 1/2, secant of pi over 3 is 2 over 1, or just 2. So this ends up becoming 2 times 2 squared, because it was secant squared, which is 8. Right, so because cosine is 1/2, secant is 2, and we're squaring it, so it's 4. And then 4 times 2 is 8. All right, this one is a non-calculator. 28 was a non-calculator as well. The way you can tell if they're calculator or non-calculator is what number they are. So if they're a number that's like 70s or bigger, it was a calculator question. Right. So next one is, again, no calculator. Which of the following statements are true? They gave us a piecewise function. So the limit as x approaches 2 from the left equals the limit on the right. The limit of the derivative on the left is equal to the limit of the derivative on the right, and f is differentiable. So this one, number 1, is just basically plugging in 2 to both of these. So that's ln of 4 times 2 is 8. 8 minus 7 is 1. And we need to have memorized that the ln of 1 is just 0. When we plug in, we get 0. Then here, 2 times 4 is 8. 8 minus 7 is 1. Well, 0 is not equal to 1. So this one is not true, which means also that when that one is not true, now it's not continuous. If it's not continuous, I immediately know it cannot be differentiable. So really my only answer is B. But let's just make sure. So if we do f prime of x, we're going to get chain rule on this one. ln of x is 1 over 4x minus 7. And times the derivative of 4x minus 7 is 4. When x is less than 2. And then here the derivative of 4x minus 7 is 4. So when we plug in, we can make this 4 over 4x minus 7 if we want to. When x is less than 2. And then 4 when x is greater than 2. So we plug in 2 here to the derivative. 4 over 8 minus 7 is 4 over 1. We get 4. And that's just going to also give us 4. So the derivatives, the limits of the derivatives, those are equal. But why is it still not differentiable? Even though the derivatives were equal, it's still not differentiable because it was not continuous. Okay, so in order for it to be differentiable, it had to also have been continuous. Both of, when we plugged in the original and when we plugged in the derivative, they should have been equal to each other. So, basically differentiability, both of these things have to be true, is, it has to be continuous and the limits on each side have to equal each other. All right, here's another one, kind of similar, but now they say f has a limit, f is continuous, f is differentiable. So this side is the limit side, and this side is the f of 2 side. So for the limit side, the limit as x approaches 2, that's going to be the x squared minus 4 over x minus 2. You can either factor, you can do L'Hopital's, because if I plug in 2, I get 0 over 0. So I'll do L'Hopital's this time, and a lot of times I'll factor this one, but I'll do L'Hopital's. So we get 2x over 1, plug in 2, and we get 4. So the limit as x approaches 2 is 4, but f of 2 is equal to 1. So f does have a limit, it's 4, but f is not continuous, and since it's not continuous, it's not differentiable. Right? How did I know it wasn't continuous? Because here when I plugged in 2, I got 1. Here when I plug in 2, I do get 0 over 0, but it's the limit, so the limit was 4, right? So I'm not going to put 0 over 0, I'm going to put 4. That was the limit. So because 1 and 4 are not equal to each other, it's not continuous. And now because it's not continuous, it's not differentiable, I don't even have to worry about taking any derivatives. So my answer is A. Okay, next up, here's another one of these. What are all the values of a and b, which makes it differentiable at 2? This would be another good one that I might recommend that you pause and just try on your own. This is a pretty common question. It's a good one to try on your own. So if it says differentiable, that also must have been continuous. So we're going to first, do the continuous by plugging in 2 to the originals. So 2 plus 2b, right? I'm plugging it in for the x, equals a times 2 squared. That's 2b plus 2 equals 4a. So that's my first one. Then I'm also going to do the same thing for it being differentiable at x equals 2. So before I can do that, I do have to take the derivatives. It's going to be 1. The derivative 2b is 0 because there's no x in it. So 1 when x is less than or equal to 2. And then 2ax when x is greater than 2. So I'm going to set 1 equal to 2a times 2. That's 1 is equal to 4a. Divide by 4, we get 1/4 equal to a. Now we're going to take that 1/4, plug it in for a. So 2b plus 2 equals 4 times 1/4. That's 2b plus 2 equals 1. So 1 minus 2 is negative 1. Divide by 2, b equals negative half. So choice A. Yeah, I think this was on the last one too. So where is it continuous but not differentiable? Where it makes that cusp is where it's continuous but not differentiable. So choice A. All right, I think we have another one kind of similar, but this one is a limit question. So what is the value of the limit as x approaches 1 of f of g of x? So what we're going to do is we're going to kind of take this one and plug it into g of x and do the limit there. Right? So this one's a little bit tricky, but we're going to basically do the limit there. So this is like having f of the limit as x approaches 1 of g of x. Kind of, we can write it that way. So the limit as x approaches 1 of g of x is 2. So this is f of 2, which is 3. So that's kind of how that one works, is you take the f outside. All right, next one is a calculator question. So given y equals sine of 2x, what would be dy dx at x equals 3? So you just literally just do that on a calculator. We're probably not going to have a question this easy on our exam. This is from a, kind of a very older exam back in like the 60s, 70s, 80s. The calculators weren't as powerful, and they tested these kinds of questions more. Nowadays, they're not going to give us something that straightforward, but it's still a skill we need to know how to do. So I kind of skipped ahead and typed this out. Make sure that you have derivative with x. You got an x here. Make sure you're in radians. Add x equals 3, and then control enter to make sure we get the decimal version. We get 1.9203. So 1.9203. All right, I would highly recommend typing these into your calculator, making sure that you're doing it, that your calculator's in the right mode. If it's not, make sure to talk to me in class, send me an email. So velocity is given by v of t, where t is in seconds and v is in meters. What is the acceleration of 0.6? Same thing we did earlier. So just we're going to take the derivative and plug in 0.6. This time as we do that, we want to make sure that we have a t here. And then we'll just type in 5. And then same thing, make sure you use this E button. Don't use E and then power. Use this E button. It's a different E. So 5e to the negative 2t. And make sure we put the arrow over plus 4. And then outside here, we're going to do control equals at time equals, they said 0.6. So we'll get negative 3.0119 or negative 3.012 is our answer. All right, next one is a diagram. And they're asking us all of these statements are true except which one. So this one's a little bit tricky. We have to just kind of go through each one, but this is a really good AP question. So they say the limit as x approaches 3 from the right is equal to the limit as x approaches 3 from the left. Well, from the left and the right, those limits are equal. Okay, the limit as x approaches 5 is equal to f of 5. That would be the definition of continuous. Well, it is continuous at 5. All right, C, the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h is 0. We have to see this, and we have to immediately recognize that that's f prime of 2. saying f prime of 2 is equal to 0. Well, at 2, we do have a horizontal tangent line, so that is also true. The next one is saying the limit as h approaches 0 from the left is equal to the limit as h approaches 0 from the right for this. This is going to be basically saying that f prime of 4 exists, essentially. F prime of 4 from the left equals it from the right, which essentially is saying, this here, when you see this, the derivative on the left equals the derivative on the right. Basically, what they're asking you is f differentiable at x equals 4? So this isn't tested very often, and it's not really a formula I necessarily expect you to memorize, but we should be able to figure it out. And anyways, you can kind of see it's a jump here anyways. So even if you weren't totally sure, you see the jump, it's probably that answer. And then the last one is kind of a tricky one. It's saying that the limit as x approaches 2.5 of f of x is bigger than this derivative. Basically what it's trying to ask for is that, f of 2.5 is bigger than f prime of 2.5. Well, if we look, at 2.5, it's sloping down. So it has a negative slope, but it's above the y-axis. So we know this is positive, but its derivative is negative. That makes sense. So our answer is definitely choice D. Now notice, I like to do this, is when I think the answer is D, I still check E just to double check it to make sure that that one's also false. Because sometimes, you're maybe not totally confident about D, so you check E to make sure. All right, next one, let f be a function such that the limit of as h approaches 0 of f of h 5 plus h minus f of 5. So again, we see that, and that's basically telling us that f prime of 5 is equal to 3. That's what they told us. So they told us f prime of 5 equals 3, which must be true. F of 5 equals 3. No, that doesn't have to be true. F of 5 has to exist, but we don't know what the answer is. Why does it have to exist? Because if f prime of 5 was 3, that means that f is differentiable at 5. Well, if it's differentiable at 5, what did it have to be? It had to be continuous at 5. So if it's continuous at x equals 5, well then yeah, f exists, but we don't know what it is. It could be any number. F prime of 5 equals 3, that has to be true, because that's literally what this means. That means f prime of 5 equals 3. And f is continuous and differentiable. Yes, that also has to be true, because I'm going to just put check marks here, actually, make it cleaner. That also has to be true because if f prime of 5 has an answer, it had to be differentiable, which made it have to be continuous. So our answer would be E, 2 and 3. All right, next one shows us a graph. And again, it says which statement is false. So f is continuous but not differentiable at a. That's true. It's making a kind of cusp. So that one's true. Then the limit as x approaches a from the left is equal to the limit as x approaches a from the right. And so this one is saying that basically, again, that f is differentiable at x equals a. Right? Well, that's not true. We just said it wasn't. Now let's just check through the other ones. F of a is defined, but f of c is not. Well, f of a is defined. F of c as a whole, that's true. F prime of b is 0. That's also true. It's making a horizontal tangent there. And the limit as x approaches c on the left is not equal to the limit as x approaches c on the right. Okay. So that one is false. I misread this because they are equal, right? Even though the f doesn't exist, the limits are the same, right? It's approaching the same thing. So that one's also, basically false. Oh, okay. So you know what? I think I might have messed this question up. This is a question. Yeah, this one. Let's see. Let me look at this. This one, it looks like has 2 answers. This was from a textbook. So when they say which, there might have been more than one right answer. It might have been like one of those ones where you can pick more than one answer. I took this from a textbook, not an AP test. So both of those look to be false, right? Because those limits are equal, right? The limit as x approaches c from the left side of f of x does equal the limit as x approaches c from the right side of f of x, right? Because they're approaching the same thing, it just doesn't exist. And then b is also false. Oh, you know what? No, I just misread this. It is b. B, it says is not equal to. Yeah, they're not equal. That's true. So f, this is saying, is f differentiable? No, it's not. But when we see the not equal to sign, they're saying it's not. So this is actually saying f is not differentiable because it's the not equal sign. I just misread this. So that one is false. That one is, or sorry, true, 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 true. And then this E is the false answer. Right? So because it's making the cusp, it's not differentiable because as the not equal to sign, then it's telling us that they want it to not be differentiable. So I just misread that question. So our answer is E. And that's another one. That's a really good example of why I check each answer. Is I checked each answer and I saw E and I'm like, okay, E is definitely false. So I went back and I rechecked B and I realized that I misread it. So it's good practice. All right, and then this is, I think, our last two questions. So they give us a table question. And this is written in really kind of a funky notation. Again, this was from a textbook. I've never seen this notation on the AP exam. On the AP exam, they'll usually do something like h of x equals f of g of x. And then they'll ask us for h prime of 3. But this is the same concept, okay? So if I was doing it that way, h prime of x equals f prime, the outside, of g of x times g prime of x. We did something like this earlier. H prime of 3 equals f prime of g of 3 times g prime of 3. So that's going to give us f prime of, so g of 3 is 1 times g prime of 3. G prime of 3 would be negative 5. So I'll just put in negative 5 here. So f prime of 1 is 3. 3 times negative 5 is negative 15. This is absolutely a question that you need to know how to do. It's supposed to be a star. It doesn't really look like a star. But this is absolutely a question we need to know how to do. And then last one is let f be defined as this function. And they ask us for what value k will the limit from the left equal the limit from the right. Well, basically what we're going to do is we're just going to take the limit as x approaches 1 from the left of cube root of x plus k. Set it equal to the limit as x approaches 1 from the right of ln of x. Because this is the left side less than, this is the right side greater than. Now both of these actually we can just do with direct substitution. So cube root of 1 plus k equals ln of 1. Cube root of 1 is 1. 1 plus k equals ln of 1. You have to memorize as 0. So we get k equals negative 1. So with ln's, make sure that you memorize a few things. The ln of 1 is 0. The ln of e is 1. And then the ln of 0 you want to memorize is undefined. And then also, maybe memorize the graph as well. The graph looks like that. And that's at the point 1. All right, so that's it. I said we're going to skip the free response. The only one that you may want to do, it's a good question for practice, is you might want to do this one right here, question 3. Okay, maybe try to do this on your own. This is a really good question, kind of going over some of the stuff that we just did. And if you do that on your own, we might kind of do this as a warm-up tomorrow in class. So you'll have that ready, and we'll just go over it tomorrow at the beginning of class.